Okay, so this is still section 4.3, and I just want to do a few examples that you might see in the homework, right? So this says we want to evaluate without a calculator. Now, you might be thinking, wait a minute, right? On our test, we can always use a calculator, right? When you're doing homework, you can use a calculator. Why do I have to put my calculator away for this? Well, short answer is you don't. You're welcome to use your calculator, right? As long as you know the change of base formula, you can do this. And to be fair, most of your calculators by now, I think the TI-84s, they have a feature that you can do this directly, but I don't have one of those calculators. So if you do the math menu and you scroll down a bit, you might be able to find this on your calculator. So if you can do that without the change of base formula, great. But some of you might not have that feature, and so I did it the long way using the change of base formula, right? So yes, the way to do this with a calculator, right, which is in this problem I guess would be cheating, is to use the change of base formula. So you're just going to do log of 49 divided by log of 7, and you put that in your calculator and it says 2. So there's the answer using a calculator. But okay, how can we do this without a calculator then? Right, and maybe now it's kind of obvious, right? You're looking for some number. I'll just call it x. So we're looking for a number x, right? And if we convert this back to an exponent, right, we're going to kick the 7 to the other side, knocking the x into the exponent, and that's what equals 49. So the question is, 7 to what power is 49? Well, it's not 7 to the 1, that's 7. What about 7 to the 2? That's 7 times 7, and that's 49. Well, there you go. The exponent is 2, and that's why the answer is 2. X equals 2. So, yeah, so we didn't need our calculator because we can just look at this exponential and kind of guess the answer, right? Yeah, let's do another one. So, oops, sorry. Let's scroll down a bit here. Okay, so let's calculate log of 1,000. What's the log of 1,000, right? Without a calculator now, without a calculator. Because I know this is very easy to do on your calculator, right? So we don't know what this is. I mean, if it's not obvious, let's give it a name. Let's just call it x, right? We're looking for x. And notice what's b here. So how did I go from here to here? I used this. I used the fact that log base b of m equals n is the same thing as b to the n equals m. I just wrote it backwards, but it's the same thing, back and forth, right? So now my b is this number here. There's no number. Well, then you should know that that means it's 10. If you don't see a number, you can always just put a 10 there, right? So b is 10. And my n is just x. And my m is the number 1,000. So the question is, can we solve this? Do you know what power of 10 is 1,000? Well, let's guess. It's not 10 to the 1 because that's 10. It's not 10 to the 2 because that's 100. What about 10 to the 3? That's 10 times 10 times 10. That's 1,000. So there we go, right? This x has to be 3. So I'm going to just put in a 3 here. Yep, so log base of 1,000 is 3. And of course you can use your calculator and check. In fact, you don't need the change of base formula. Just put in log of 1,000 and it'll spit out 3. Right? Okay, let's do a few more. So part C. How about, oh, this is a good one. How about e to the power ln of 7.21? Okay, so before you grab your calculator, remember we don't want to use a calculator here, right? We just want to use the properties of logarithms and exponents, right? So this, we don't know what this is, but we know that this is going to be b. And remember, well, remember what ln is, right? ln is log base e. So this is the same thing as e to the power log base e, I hope that's not too small, of 7.21, right? I'll scroll down here, right? So, yep, we have this following property here that, I'm running out of colors here, right? So we have b to the power log base b of x. Well, that was equal to x as long as x is positive, right? So this is a b, not a 6, b. So yeah, b here, of course, is just e, and the x is this number, 7.21. So yeah, these b's cancel, and you just get x, which is 7.21. Right? And that's because the exponent canceled this logarithm here, right? So just knowing that property, we were able to get the answer without having to use our calculator. Of course, your calculator should tell you the same answer. Okay. So I guess let's do another one. Can I go over here? Part D. Yep. How about log of the cube root of 10 to the power 7? Okay. Again, without a calculator, right? So what do we know to do here? Well, we know that, again, when there's no number here, we can always just stick a 10 in there because it's log base 10. And so this is log base 10 of 10 to what power? Well, hopefully you remember from your algebra days that you just get 10 to the power, well, I hope you remember this. It's not 3 over 7, right? It's 7 over 3. Okay, so just converting a radical, I shouldn't use x, right? I'll use a to the m, right? That's just a to the power m over n. So that's what I did there. And now, right, this 10 and this 10 cancel because this is the exponential 10, this is logarithm 10, so you should just get 7 over 3. Right? And your calculator will tell you the same thing. Well, your calculator will say 2.333333, but you know how to convert that to a fraction, right? It's 2 1/3 or 7 over 3. At least I hope you know how to convert that to a fraction. Okay. Well, okay, I'll tell you, right? If your calculator says this, and keep in mind, I'm not going to accept this because it's an approximation. Without the dots, it's an approximation. So if you hit math and then enter a second time, math, enter, enter, that will convert this. It'll say 7 over 3. Okay, so very handy technique to convert decimals to fractions. It doesn't always work, right? It's not going to work with, with things like 2.7931261, right? If you try to convert that to a fraction, it'll just spit out the same number again. It won't work always, but it works for most small fractions like this, okay? All right, one more, and I'll let you think about this for a second. So this will be part E. Yeah, so calculate, without a calculator, log base 3 of 3 to the power negative 97. Well, I hope you got negative 97, right? If you're thinking it's undefined, well, be careful here, right? It's not undefined, right? This is log base b of b to the x. This is equal to x for all x, for any real number x. Positive or negative does not matter. So, right, because you're not taking the log of a negative number, right? So here x has to be positive because you're taking the logarithm of x. Here we're not. Right? We're taking the logarithm of this number, 3 to the negative 97, and 3 to the negative 97, while it's a very small number, it is positive. So this whole number here, well, it's not a whole number, it's a decimal, right? It's a very tiny number. But it is a number, right? It is a positive number, and so you get this as your answer, right? So one of my favorite questions to put on tests, and obviously I can't do that because you're taking it on Connect Math. But if I were to give you this problem, right, let's say what's the log base 2 of 2 to the power negative 1 million. 2 to the power negative 1 million. I'll let you think about that for a second. Yep, you should get negative 1 million. The comma's in the wrong place. Comma's there and there, right? You can also write this as just negative 10 to the 6. I'm okay with that. Right. Now, for those of you that got undefined, you cheated, right? You used your calculators. And remember, you're not supposed to use your calculator for these. Now, if your calculator says undefined or it gave you an error of some kind, what happened? Well, see, here's the problem, right? Your calculator doesn't know what to do with these numbers here. This number here, the thing you're taking the logarithm of, this number is very, very small. It's so tiny that the calculator can't deal with it. What your calculator does, right, because this number is so incredibly tiny, it rounds it. The calculator rounds it to 0. And so when you take the log of 0, remember that's undefined. And so that's why your calculator spits out the wrong answer. It spits out an error. So your calculator doesn't understand this property here. It doesn't, right? It doesn't understand this property here. So it tries to do this one step at a time. It tries to calculate this. It says, oh, okay, it's close to 0, so I'm just going to say it's 0, and then try to take the log of 0, and your calculator just doesn't know what to do with that. In fact, it can't, because log of 0 is undefined. Right, so if the question is, what's the log of 0, your answer would be undefined. But if your question is, what's the log base 2 of 2 to this very tiny number, the answer is the exponent, negative 1 million, or negative 10 to the 6, either way. Right? It's not undefined. Right? So this is a warning to you. When I say evaluate without a calculator, well, for a lot of problems, for most of these problems, you could use your calculator, and it'll give you the correct answer. But for this problem here, it'll actually give you the wrong answer. And so on a test, if you put undefined, I'll know what you did. I'll know you used your calculator when you're not supposed to. So use your calculator, but use it carefully, because in some problems, the calculators are not perfect. They will give you incorrect answers in some cases. So just be aware of that. Okay, I want to do one more because I think this might come up in the homework. And this is a sort of a, related question, but we're not using our calculators here. We want to find the domain of the function f of x, right, equals, let's just do log base 5 of 3x minus 18. Okay. So we just want the domain, right? We're not trying to plug in numbers or calculate anything here. We just want to find the domain, right? Right. So if you remember, when you have the log of something, right, the log of x, and it doesn't matter what the base is, that x has to be positive, right? You cannot take the log of negative numbers. Okay. Now, what's our x in this problem? It's not just x, it's this whole thing. It's 3x minus 18. Right? So take the 3x minus 18 and set it greater than 0. Right? Be careful, don't put an equal sign here. It's not equal to 0, right? This is, x is strictly greater than 0. Right? Remember, we just said you cannot take the log of 0. So for that reason, there's no equal sign here. So be careful, right? All right. So I'll let you solve this. It'll take 10 seconds, right? Yeah. Add the 18 and divide by 3. Right? We're dividing by positive numbers, so we don't flip the inequality. So 18 over 3 is 6, so we just get x is greater than 6. Right? And there's the answer, right? The domain is x is greater than 6. Oops, sorry, that's not the answer. I didn't mean to box it. I meant to highlight the fact that this is greater than 0. But the domain here is x is greater than 6. However, remember we want interval notation, so that's from 6 to infinity. Right, so that's interval notation. Okay. Right, again, no bracket, because remember if you use a bracket 6, that's the same thing as saying x is greater than or equal to 6. But remember, we just said we don't want this equal here. So yeah, be careful you don't put a bracket, because that would be incorrect. We don't want it equal to 6 here. Because what happens if we plug in 6? We get, well, you can check, right? You get the log of 0. You get 3 times 6 minus 18. But 3 times 6 is 18, and 18 minus 18 is 0. But remember, you have to take the log of 0, which is undefined. So for that reason, you cannot plug in 6. But you can plug in 6.1, right, or 6.001, or you can plug in 119, anything bigger than 6, right? You can plug into this. But you cannot plug in 6, you cannot plug in 5 or 4 or 3 or negative 18, right? It's just not going to work, right? So I think that's it, right? So find the domain of a log function and be able to calculate these without a calculator, although I can't stop you, right? If you're going to use your calculator, go right ahead. But just as a warning, for some problems it might not work, right? Like for f here, right? This did not work. The calculator said undefined or error, when in fact it had a legitimate answer. And so you have to be careful of that. Okay, so I think that's, oh, you know what? Yeah, let's do one more. Let's do one more, and I'm just gonna clear all this. Okay, last one. This is a word problem. So there's a couple word problems that might be in the homework, and so they could very well be on the test. But there won't be a lot of them. Okay, so the pH scale measures the concentration of hydrogen ions. Okay, so for those of you that are going to take chemistry, you're going to have to know this, but for now, pH is just a number that represents how acidic or basic a substance is, right? So water should be 7, right? And I think it's 7, right? Pure water should be 7, and the more acidic, it should be less than 7. Basic is greater than 7, if I remember right. So here's the formula for pH, and I know this is kind of tiny, so let me write it down again here. So the pH is a number, and it's just the negative of the log base 10 of this number here. This is, in brackets, this is the concentration of hydrogen ions in the substance. Okay, so that's the given formula. You don't have to memorize that. You don't have to know that, right? This is given in the problem. It's right here, right? Okay, and so part A says that baking soda has a pH level of 9.5. So what is its hydrogen ion concentration? In other words, we want to find the concentration of hydrogen ions. Okay, so how do we do that? Well, let's just use the formula, right? The formula is given, so the pH is on the left side. That's the 9.5, and that's going to equal minus negative log of the H plus, right? That's what this is. And don't forget, this is base 10. Right. So how do I solve for this variable here? I know this is an awkward variable, but think of that as just x, right? Think of this as just solving for x. Right. In fact, I'll put the 9.5 on the right because, yeah, it's more convenient there. Okay, right, so again, we're trying to solve for x here, right? So how do you solve for x? Well, this is a logarithm. How do you undo a log? Well, actually, before we do anything with the logarithm, notice that there's a minus sign here. So why don't I just multiply by -1 on both sides? Oops, I didn't mean to cross that out. Multiply by -1 on both sides. And if I do that, I just get positive logarithm, again, base 10. You don't have to write the 10, but let's do it. It's convenient. And that's going to be negative 9.5, right? Negative 1 times 9.5, right? All right, so now we want to solve for x, right? And the way to do it is we're going to treat this as a logarithm, right? Remember, log base b of n equals m. I think I got it backwards. Yep. Log base b of m is equal to n means the same thing as b to the n equals m, right? Or m equals b to the n, same thing, just written backwards, right? So you can see what we want to do here. If we want to solve for x, right, we want to solve for m. So to solve for m, you convert this to an exponent. You kick the 10 to the other side, right, knocking the negative 9.5 into the exponent, right? So that's x, right? That's what we're looking for here, right? So yeah, there's our answer. Our answer is just 10 to the negative 9.5. Although I think if you plug that in your calculator, I think they want the they want the actual approximation here. So this is approximately 3.2 times 10 to the negative 10. So that's the answer they're looking for. This is right. Remember, this is in scientific notation, whereas this is not. But look, I'm not going to be too picky. I'll accept either. But technically, this is in scientific notation. If the book says write it in scientific notation, then yeah, then I'm not going to accept this. You got to convert it to that. You lose a point for not converting. Okay, so is that make sense, right? You're solving for x. So to get rid of the logarithm, you convert it to an exponential. Okay, that's very important because I don't ever want to see this, right? Because this looks an awful lot like, oh, just divide by log base 10. Please don't do that. I already warned you. I already warned you not to do that. So if you do that, well, you get the wrong answer, right? You get x is negative 9.5 divided by log base 10 of what? See, this is the issue here. If you just write log base b, that's meaningless. That doesn't mean anything. That's just the name of the function, right? It's like writing f. F is just the name of the function. But f of what? F of x. Log base b of x. If you don't write anything after it, it's just the name of something, right? This is, right, see, the answer was 3.2 times 10 to the negative 10. This is not the answer. This doesn't mean anything, right? This is certainly not equal to this. So don't do that. That's meaningless, right? You cannot divide by log. I told you that already. I'm going to warn you again and again and again because it's a very common mistake. People like to divide by logs. You cannot divide by logs, right? Let me write it down. You cannot divide by log, right? You can divide by logarithm of a number, right? You can divide by log of x, but you cannot divide by log when there's something that comes after it, right? So you can divide by log base b of x. You cannot divide by log of itself, right? Right. I hope that's clear. So for example, if f of x, right, is equal to, 3x plus 6, right? How do you solve for x, right? You don't divide by f, right? You don't divide by f. We know that's meaningless, right? That doesn't do anything, right? So what do I mean by you want to solve for x? What I mean is you want to find the inverse, right? You want to write this as y, and if you want to solve for x, right, you find the inverse, right? So you write y equals 3x plus 6, switch the x's and y's, right? That's a 6, not a b, right? And then solve for y. So x minus 6, right? And then divide by 3. So you get y equals x minus 6 over 3. Well, if you didn't switch the x's and y's, you would get y minus 6 over 3. Right? So the inverse, and this is a good review of 4.1, the inverse function is just x minus 6 over 3. Right? But yeah, it has nothing to do with dividing by f. So, right, so just like you do not divide by f here, you do not divide by f, you do not divide by log base b. Okay? Don't do it. Well, you get the wrong answer. Right? You're going to get it wrong if you do that. So yeah, the right way to do this is to simply convert, what we did here, convert to an exponential. Right? In other words, kick the b to the other side, knocking the n, this thing here, into the x. The n becomes the exponent, right? Remember, the logarithm equals the exponent. The logarithm is the exponent. Okay, so I think that's that's a word problem, and you may or may not see a lot of those, but I just wanted to do a lot of examples in section 3 point, where are we now? No, I'm sorry, 4.3.